In this lecture, we're going to cover strings and bytes, as well as how to represent them as literals in Python. First, what are strings? Strings represent human-readable text. Strings are literally sequences of Unicode code points. For instance, the string hello in Python is the string of numbers 0x48, 48, 0x65, 0x6c, 0x6c, and then 0x6f. Each of these numbers represents a different letter in the Latin alphabet. If you go to the Unicode website, you can look them up and learn all about the letters. Unicode code points are numbers up to 0x10FFFF, which is about 1.1 million. In an upcoming video on Unicode, we'll talk more in detail about what it actually is. For now, each code point can represent a letter mark, or some kind of special instruction on how to write the letters. As of May 2019, the most recent version of Unicode has 137,994 different code points. Every Unicode code point also has a special name. You can look it up on the internet. Python also has something called bytes. What are bytes? Bytes are sequences of numbers between 0 and 255. In hexadecimal, that's 0x00 to 0xFF. Computer memory is typically arranged in clusters of 8 bits, or bytes. Bytes are not meant to be human-readable. Something has to translate it to human-readable text. Only a few encodings fit in the schema of bytes, particularly ASCII. Note that in Python 2, they had strings and Unicode. In Python 3, string became bytes, and Unicode became strings. This is the principal reason why converting from Python 2 to Python 3 was so difficult. If you're still using Python 2, it's time to stop. How can we write string literals in Python? Well, we need to delimit strings with quotes. We can use single quotes or double quotes. We can also use triple single quotes or triple double quotes. When we use single quotes, the strings cannot span multiple lines. However, we can include the escape sequence \new line to join the lines together. For instance, this string is valid. ASDF followed by \HJKL. And that will be interpreted as the string ASDF HJKL. Triple quotes can span multiple lines and includes the new lines as part of the strings. When you have two string literals in a row, Python always concatenates them together. For instance, ASDF HJKL is the same as ASDF HJKL. Note that this only works for string literals. It does not work with expressions that resolve two strings. We can add a prefix to the string. R or R means that it is raw. It will not obey escape sequences. B or B means that it's bytes. F or F means that it's inline formatting. We'll cover that later. And finally, you can use U or U, but that means nothing. In Python 2, this meant that it was a Unicode string. There's only two symbols that can be combined together, R and F or R and B. Other combinations are illegal. Inside of a string literal, there's multiple escape sequences that you can use. We've already looked at \new line. The backslash and the new line are removed. For instance, if we had triple quote ASDF \GHJK followed by triple quotes, that's interpreted as a string ASDF GHJK. If we want to include the backslash, we use \\\. That interprets to a single backslash. We can also escape single quotes and double quotes. This allows us to include quotes in strings. For instance, it is interpreted the same as its. Okay. There are some ASCII code sequences that we can use as well. A is the bell. B is the backspace. For instance, print this out. A/B, B. /F is form feed. I haven't really found a use for this. /N is a new line, what we call LF, or new line. /R is the carriage return. Typically, you'll see /R/N for Windows and Internet documents. /T is a tab. /V is a vertical tab. Vertical tab. I have no idea what that does either. If you have slash followed by 3 octal digits, that's interpreted as octal. For instance, /101 is the letter capital A. If you have /X followed by 2 hex digits, that is the hex. For instance, /X41 is also equal to A. You could include Unicode by name with capital N followed by a curly brace and then the name of the Unicode code point. You can include 4-digit Unicode code points by lowercase u followed by 4 hex digits. And you can use uppercase U with 8 hex digits for 32-bit code points. In Python, if you have slash followed by anything else, it's left as is. However, right now that'll raise a warning, and in the future, that'll be considered a syntax error. So I recommend you don't do that. There's a bit of an issue with raw strings and escape sequences. For instance, in a raw string, we can do the following. That's R followed by a double quote, followed by a backslash, followed by a double quote, followed by a double quote. This is interpreted as a string that only has 2 characters, slash and a double quote. However, the following raw sequence is illegal. Python cannot interpret this. If you need to have a string ending with a backslash, you can always just use a regular string with double backslash at the end. And don't forget that you can concatenate literals. So you can have the raw all the way up to there, followed by this, and that'll get what you want. In functions and classes, if the first line after the definition of the function or the definition of the class is a string literal, then that's called a docstring. Here's an example. Def myFn. This is myFn. You can access the docstring by using the __ doc method, or attribute rather. And that will give you, this is myFn. Typically, docstrings span multiple lines, so we use triple quoting for them. And if you were just to look at the string, it would include escape sequences, so it's not very useful. So we print the docstring to see what it's supposed to say. We can also use the help function in the interpreter, which will nicely format the docstring as well as the methods and attributes of the object. What are docstrings used for? Well, in documentation systems like Sphinx, in the autodoc feature, they will take the docstrings and build documentation listing all the functions and all the classes and attaching the docstrings as part of the documentation. What should you include in the docstring? Well, you should typically include a brief description of what the function does or the class, followed by a description of the parameters, what types they should be, what values are expected, and then a talk about the return value, what kind of type it will be and what values it might have. Finally, you can include a more detailed description of the function after these things are spelled out. There's two popular formats for organizing these comments. One is called Google Docstring, and the other is called NumPy Docstring. It seems the Google Docstring is more popular. I recommend you read about the Google Docstring standard and use it in your code from now on. I won't go into detail about all the functions that can be used with strings and bytes. I'm just going to cover a few functions that are very useful. First is str. str will convert the arguments to a string. Give it a try. See what happens when you pass in different numbers or different things. There's also bytes. This will convert the parameters into bytes if it can. Note that if you passed a sequence of integers, this will convert it to a stream of bytes. As an example, if we called bytes with 1, 2, 3, and 4, this will give me the string /x01, /x02, /x03, /x04. There's also ORD. ORD will take a character from a string or a byte and will convert that to a number. For instance, ORD of uppercase A will give you the number 65, I believe. ORD of the exclamation point will give you 33. If you want to see the hex of that number, you should pass that into hex. So hex, ORD, and that. We'll tell you what the hexadecimal for that is. CHR does the reverse. It takes an integer and converts that to a single length character, a string. For instance, CHR of 65 will give you A, and CHR of 33 will give you the exclamation point. Don't forget that you can use hexadecimal literals as well. So 0x21, that's actually the exclamation point as well. There's also len. If you pass a string into len, it'll tell you how long that string is. And you can do simple subscription. So you take the string, use a square brace, and then put an integer in there. This will give you the 6th code point in the string. S0 will give you the first code point, and S of len of S minus 1 will give you the last. You can also use negative indexes. For instance, S of -5. This will give you the 5th from the last. This is interpreted as S of len of S minus 5. If you go outside of the bounds, you'll see an index error. There's a lot more you can do with the square braces and the subscription pattern, especially slices. We'll cover that later in a later lecture. I hope you enjoyed this lecture. Take care and bye-bye. Thank you for watching this video on the theory of Python by Real Physics. Be sure to subscribe and ring the bell, like and share this video. You can find me on Discord or support me on Patreon. Links are in the description below. Thank you so much. Have a great day. Bye-bye.